the last objective, the last thing we're looking at in this section is forming the sum difference product and quotient of two functions. So we've defined functions, we've looked at domain a little bit, used function notation, done some things with functions. So now we can kind of actually say, well, what's the point? What can we do with functions? Well, we can actually do operations with functions just like we can numbers. In other words, we can add two functions together, subtract two functions, multiply or divide two functions. And so here we have our definition of those operations. And really the cool thing about this is it's almost exactly what you would expect. If you want to add two functions together, the sum of two functions f and g, here's our definition. Now notice the notation here, f plus g of x. That shows that I'm adding f and g, those two functions. That's just the f of x, the first function, plus g of x, the second function. So that's almost, if you had to guess what it would be, that's probably what you would guess, adding the two functions together. The difference, same thing, you're just subtracting. Product and quotient, okay, multiply f times g, the two functions, and then divide, f of x divided by g of x. So, in kind of the definition, it's pretty simple of what those operations look like. Now, what's not so simple is when you start talking about what's the domain of that new function. If you add two functions together or subtract two functions, what's the resulting domain of that new function? So that's going to be the tricky part of answering these questions. And so we'll cover these notes here in just a second. First, let's just look at a couple of examples of adding two functions together, subtracting two functions. So what is f plus g of x here? Notice I've got f of x is 1 over x plus 2, g of x is x over x minus 1. We want to know what's f plus g of x. Well, my definition, if you'll remember, is f of x plus g of x, to add those two, and so that's just the first function plus the second function. Now if I'm going to add those two together, I want to simplify this. I need a common denominator. Now if you'll remember adding rational functions or adding rational expressions, a common denominator, I need to look at the common factors of those denominators. So the first fraction, 1 over x plus 2, x plus 2 is a factor. The second fraction, x minus 1, in that denominator is a factor. So my LCD, I just need to put those together. That's the LCD of these two fractions here. So my two fractions need to be x plus 2 times x minus 1. So those are going to be my new denominators. Now the question is, for this first fraction, I had an x plus 2. I was missing the x minus 1, right? So since I had to add in an x minus 1 here, I'm going to take this numerator and also multiply it by x minus 1. So there's my new first fraction. Over here I had x over x minus 1. In that denominator I was missing the x plus 2, so I added that in. Well, that means in my numerator I got to multiply by x plus 2 there as well. And we'll get to that here in just a minute. I'm going to need some more space. So simplifying this down, I can distribute the x there. Here 1 times x minus 1. It's just x minus 1. Okay, keeping that LCD. This is x squared plus 2x. And then I can pull all this together now that I've got a common denominator. We've got x minus 1 plus So since I'm adding, I can just pull all this together. X squared plus 2x. And then if I combine some like terms, I get x squared plus 3x minus 1 over that LCD x plus 2 times x minus 1. So simplifying it down, that's my final answer there for adding those two functions. Now, they're not all that bad, okay? Not all the questions are this terrible. This one was tough because our original functions were fractions, so we had this whole mess of trying to get a common denominator to put those together. You'll find when you get to the homework that they're not all this horrible. Okay, if you're looking at that thinking, "Holy cow, I'm never going to make it through this," okay, just trust me on that. Okay, they're not all that bad. So let's think about the domain of this new function. Okay, so I started with these two functions, f and g, and then I put them together to get this new function. Now, because I'm starting with these two f and g functions and using those to build a new function, the idea is that anything that doesn't work in the original two functions, in other words, any value of x that breaks one of those original two functions, is also going to break the new function. Okay, so basically when we talk about the domain of x plus g of x, we need to go back to the original two functions and figure out what x values didn't work up here. So we can hopefully look at these first two functions and see that if x plus 2 is in this denominator, for this first guy, f, x can't be negative 2, right? Because that would make this denominator a 0. For g of x, x can't be positive 1. Okay, so those are restrictions we had on our original two functions. When we get down here at f plus g of x for the domain, we're also going to say x can't be negative 2 or positive 1. Okay, because those two values didn't work in the original function, they also are not going to work in the resulting f plus g of x function. And I think if you look at this denominator, you could reason out, okay, if I put a negative 2 here, negative 2 plus 2 is 0, times all this is going to make a big fat 0 in that denominator, so clearly negative 2 doesn't work. You can say the same thing about 1 in x minus 1. It's not going to work either. So that would be our domain. Again, we could write this as an interval. Everything except negative 2 and 1 is going to look like this. Okay, we could write that domain as well using the interval notation. Now this, what I just said about the domain, is true for addition, subtraction, and multiplication. So in other words, when we start adding, subtracting, and multiplying two functions, if we know the domain for addition, it's the same for subtraction and multiplication. So this right here is the domain of f plus g of x, f minus g of x, and f times g of x. Okay, all three of those share that same domain. So that's good. Okay, that's extra work we don't have to do. Once we know the domain for addition, it's true for subtraction and multiplication as well. So let's work through the subtraction bit. I'm going to add a new page in here because I ran out of room. So if I'm subtracting the two functions, let's go back. 1 over x plus 2, x over x minus 1. Subtracting those two now. Again, you need a common denominator, but if you're clever, you'll notice that, well, a lot of this work I just did finding a common denominator, rewriting these functions, all the way up to this step right here, I can reuse on this next problem. I just changed this addition to a subtraction sign. So in other words, I can say this is x minus 1 over that LCD and then x squared plus 2x over that LCD. So I'm just reusing that common denominator work I did on the previous example with the addition. Now when I put this together, I gotta be careful pulling these numerators together because I'm subtracting now. So I've got to be more careful about my signs. Strictly speaking, really I'm looking at this second piece here needing to distribute this minus sign through. So I get x minus 1 minus x squared minus 2x. And then I can combine some like terms here. I'm going to get a minus x minus 1 for that numerator. And there's my final answer for f minus g of x. Again, the domain, same as the previous. X can't be negative 2. X can't be positive 1. Okay. Or we could write that with intervals. We just copied that from the previous because again it's the same for addition, subtraction, and multiplication. Which brings us to multiplication. Now believe it or not, this is actually a lot easier than what we just did. If I'm multiplying these two, I think you guys are going to like this one. F of x times g of x, it's 1 over x plus 2 times x over x minus 1. If you remember to multiply fractions across the top, 1 times x is x. Across the bottom, x plus 2 times x minus 1. There it is. Got it. And what's the domain? The same. This can't be negative 2 or positive 1. And then the last one, division. Let's look at that real quick here. This is f of x divided by g of x. So I'm dividing. This is looking like a mess, right? I'm dividing those two fractions. But remember that dividing two fractions, if you divide, maybe it's a little more clear if I write it like this. Use the old division symbol. Okay, hopefully maybe now you're seeing that, okay, if I'm dividing by this fraction, that's the same as multiplying by the reciprocal, right? So I can do that. And now just multiply across, I get x minus 1 in the numerator, x plus 2 times x in the denominator, and we can call that good. We can just leave that denominator factored out, it'll be fine. So that is f over g of x. Now the domain for division is a little bit different. Now we would still say that x can't be negative 2 or positive 1, the same as the others. So if we state the domain here, let's say x such that x can't be negative 2 or 1. But there's actually another x value that's going to pop out of this thing that's not going to work. I want you to look at this piece right here. That x right there, if you think about that denominator, if we put an x value of 0, doesn't that break this? 0 times x plus 2 is going to be a 0, right? So we end up with a third x value that causes this denominator in f over g of x to be 0. So division's a little bit different. We have to kind of be a little more careful about division, and basically what you need to do is go ahead and eliminate whatever values break your original function. In this case, negative 2 and 1 from the original functions don't work. Okay, remember that's These two here, negative 2 doesn't work, positive 1 doesn't work. But then once you finish your division and get it simplified down, you need to double check and just see if there's any other x values that break this thing. And here we ended up with this factor of x in the denominator that gave us a 0 value that breaks the function as well. Now the question is, where did that come from? Why suddenly do we have another value that breaks the denominator? And what it comes from is when you have this right here. This is our definition of division, dividing two functions. Notice you've got g of x in the denominator. So the question is, are there any x values that cause g of x to be 0? Because if any x value that makes this g of x 0 obviously is going to break this fraction, right? Well, if you look at our g of x here, when is x over x minus 1 0? Well, if you just multiply both sides by x minus 1, 0 times all that is 0. Well, there's that x value 0 that we came up with right here that breaks it. It's the x value that causes g of x to be 0. Now, you don't really have to know that. If you'll just check that denominator when you're done and see if there's any other x values that break it, then that right there is enough to know those extra values that break the function. Okay, well that wraps up section 3.1. It's kind of a long section getting started, but again, it's really fundamental stuff that we're going to need as we start talking about functions really for the rest of most of the semester. So take a look at the homework. If you have any questions, feel free to email me or get in touch with me through Math Lab. If you come across a question that you're having trouble with, just hit that button. You can ask me, and I'll be glad to get back with you as quick as I can.